Corporate finance, practice problem using Excel. Retirement scenario, which will utilize the present value of an annuity and future value of annuity calculations. Get ready, it's time to take your chance with corporate finance. Here we are in our Excel worksheet. If you have access to the Excel worksheet and would like to follow along, we are in the practice tab down below as opposed to the example tab in essence being an answer key. We're going to have our information on the left-hand side. We're going to populate that information into the blue area on the right-hand side, doing a few different calculations for each component of the practice problem, which will include a present value of an annuity calculation and future value of an annuity calculation. Scenario being retirement planning scenario. So this is kind of a standard scenario that we might have in a retirement planning type of situation. We're going to imagine that the years that we have to retire are going to be 25, and we're going to be saving up then, of course, for that point in time of retirement. Annuity at retirement is what we would like to set up. So once we're at retirement, we're planning for and would like to set up and are projecting the annuity for $26,000 for 24 years. So we'd like to have an annuity that we would get at retirement 25 years from today, which would last another 24 years and pay us each year at $26,000. We're going to assume here, and this would be an assumption that we would have to make when thinking about these types of plans, and once set up, they might be an assumption that you would then adjust as you're thinking about, what might actually happen. You might run different scenarios, and if you set up your Excel worksheet properly, you can do that. We have the rate during the earnings years. We're going to say is the 10%, and the rate during the retirement years, we're going to assume to be the 12%. So when we think about this kind of scenario, it's a kind of a long-term planning thing, which of course is one of our difficult situations or more difficult situations for us humans to be calculating, because it's harder for us to think out that far oftentimes. So we're going to, and it's also a little bit tricky because the way this is set up, we're going to try to plan for this annuity that we want to set up to get our yearly payment that we're going to be having. And therefore, we have to kind of think about that piece first. We've got to first think about, okay, if I want an annuity to be paying me $26,000 for 24 years, and that's going to start 25 years from now, I first need to think about what's the target number that I need to have to put into the annuity at that point in time in order for it to then calculate out. So I have to get to that lump sum number first. Therefore, I actually have to do this second calculation, or the second part of our life calculation, first to get the money that we would need, and then we can then think about how much we would need to be putting in starting today and putting in each year in an annuity type of format in order to achieve or get to that dollar amount that we would then put into an annuity that would pay us back for the 24 years at the $26,000. So that's what we will start off with. We're starting off with the second half of our lives here, the annuity kind of calculation to get that $26,000 for the 24 years. So what we want to do first is take this annuity payment and then present value it. We're going to present value it as of the point in time that we start to have the annuity payments that would then be given to us. That would be the lump sum number that we would need. So we're going to do the present value of an annuity calculation here. And we could use the present value of annuity formula down below, which would be P times 1 minus 1 plus R to the negative N divided by R. We're going to break this formula out into basically our Excel kind of worksheet table format, where we're going to have this times this in the outer column, and then we will break out then the numerator into the inner columns. So let's go ahead and say we're going to start off with P up top. P is going to be the 26,000. I might want to even highlight the thing we're focused on. I'm going to make this green here so that I'm less likely to grab the wrong numbers. I don't want to grab the wrong numbers. And then we're going to say, okay, so then we've got the 1 minus R. So I'm going to put the 1 in this column. And then we're going to pick up the 1 plus R to the negative N. So we're going to say this is going to be simply 1, and then R is going to be 12%. Percentifying that tab, home tab, numbers group, percentify, underline it, home, font, underline, adding that up equals the sum, trusty sum function of those two items. Then we'll percentify here, home tab, numbers, percentify, the 112. We're going to then pick up the to the negative N, which is going to be negative of that 12%. percentifying that. This is going to be the, I'm sorry, not the 12%, negative of the periods, which is 24 periods. And then we'll underline here, home tab, font, and underline. We'll bring this out into the outer column. This is going to be equal to the 112 shift 6 caret 24. That then is going to be needing decimals. So we'll go to the home tab, numbers, add a few decimals here, decimalizing it. Then home tab, font, and underline. Subtraction problem now. We're on the numerator, completing up, finalizing the numerator. 1 minus that whole decimal. Then we're going to decimalize this number, which is at the home tab, numbers, decimalized. And then we have the whole numerator now. Now we need the denominator, which is going to be down below. We'll put this at the 12%, 12%. We will percentify that, home tab, numbers, percentify. Underline it, home tab, font, and underline. We now have the numerator and denominator, which we'll pull out into the outer column and do our division problem, taking the numerator divided by the denominator. And then we'll percentify this one, go into the home tab, numbers, and percentify. Underline it, home tab, font, and underline. And then we could finally multiply out here. So we're going to multiply out. This is going to be the 26 times that 7.78 and so on. Let's add a couple decimals here, home tab, numbers, and a couple decimals. So that means that we need 202, 392, 21 at the end of our 25-year period in order to put it into the annuity so that for 24 more years after that point, we will get $26,000 a year if we have and assume the rate, or if we have the rate as we do the annuity at the 12%. Okay, so next we're going to have to then think about, well, how much then would we need to be putting in for the 25-year time period in order to get to that 202, 392, 21 so that we can then put it into the annuity to receive it back for 24 years at $26,000 a year. So we're going to have to think about that. We'll do that in the second half of our problem here, but we're going to recalculate this one a few different ways here, as has been our custom. So we could do this one with the tables. We'll do it with a running balance now. Let's do the same thing with a running balance, breaking down the annuity down into, instead of 24 annuities, instead of an annuity for 24 periods, we will break it down to 24 present value of 1 calculations. So we'll do that by going 1, 2, and so on. I'm going to go ahead and select those two, copy it on down, copy it on down. Then we'll center that, home tab, alignment, and center. And we're going to pick up our payments, which are going to be $26,000, $26,000, and then we'll present value them, not present value of an annuity, but present value of 1 all the way down. We're going to say this will be equal then to, and I'll put a negative, so I flip the sign, so it'll be a positive number. Present value, shift 9. The rate is going to be the 12%, which I'll just pick up here, comma. Number of periods is just 1 as opposed to 24 because we're doing a present value of 1 period out. Then comma, comma, because it's not an annuity, but present value of 1, picking up that 26,000 then and enter. So there we have that. That's going to be in here and the outer column. Let's do it again. This is going to be equal to the 26,000. We'll present value again. Present value of 1. This is going to be, I'm just going to say negative this time instead of equals. Negative PV, shift 9. Rate 12%, comma, number of periods 2 this time because it's 2 periods out, comma, comma, and then we're going to go to the future value, which is the 26,000, and enter. So there we have it. So now we have the prior balance, 23,214, plus the new balance here for the present value, and we're going to continue that on down for the 24 time periods, and after doing so, we should once again get to that 202, 392, 21. This could give us a better kind of idea of what's going on with this actual annuity. So to do that first, however, I'm going to double click on this present value. We need to take this 12% and say don't move that down. When I copy it down, Excel, when I copy that down, cell E6, don't move it down. We're going to do that by making it an absolute reference, putting our cursor in E6, selecting F4 on the keyboard, $ before E, $ before 6, absolutizing it. We only need to make it a mixed reference, but absolutizing it is easier in my opinion. So we'll do that. We're going to select these three. Autofill, putting our cursor on the autofill handle and pulling it down 24 periods. And then at the end of those 24 periods, we have, once again, that 202,392, and we get a better kind of idea of what's happening in terms of a present value of one type of calculations as we pull back each of these 26,000 payments to the, the starting point of the annuity. So now let's go back and let's do this with a present value of an annuity function in Excel. This is probably the way that you would first do it in Excel, and then possibly want to do it this way in practice. We'd probably say, let's just do it the easy way with the Excel function, and then maybe do this kind of running balance because it gives you a better idea of what's actually happening. So let's do this one. I'm going to say negative instead of equal, so it'll make it a positive number when we're done with this thing. Present value, shift 9. We're picking up then the rate, which is going to be this 12% over here, comma. Number of periods is going to be the 24. Let's pick it up down here this time. 24 is going to be down here. And this one is an annuity, so comma. So we are going to pick up the payment rather than the future value because this is an annuity calculation at the 26,000. There, once again, 202,392.21. So we'll do this one more time before we go to the second half of the problem. And this is going to be done with the tables. So we're going to say payment is going to be 26,000. We got to pick up the amount from the table. So let's take a look at our table. Take a look at the table. That's good. We are then looking at the 12% and 24 on the periods. 12 and 24. So 12 and 24. So there's the 12. We're going to go down to the 24 periods, which is down here at the 7.7843, 7.7843, 7.7843, 7.7843, 7.7843. If you need to percentify that, then add decimals, or if you need to decimalize it, add decimals. Multiplying this out, and once again, we added 2 decimals down here. So if you need to do that. Notice this is slightly different than the present value over here due to the fact that we have rounding out to 4 digits. Okay, let's finally get to the second half of the problem here. So now we've determined that we need about this amount for the annuity, and that's going to happen 25 years later that we need to put that in so that we can get the annuity. So now we have 25 years to get that amount, and we're going to have to say, well, how much could I put in if I have a standard amount that I'm putting in standard each year to get to that 202,391? Or let's put the amount down here. This is going to be equal to, let's pick it up over here so it's more exact, the 202,392.21. So we need to get to that number by putting money in for 25 years. So that's going to be our objective now. That means the way to get there, or one way we can get there, is do a future value of an annuity calculation because we need to be at the 202,392. Now, normally when we do a future value type of calculation, the end result is the future value. But right now, what we want to do is back into the payments so that we can get to the future value. So one way we could do that is, of course, take this formula and then back into P. So the future value would be the 202,392.21 equals P, unknown, times 1 plus R. And R in this case is going to be the 10%. Let's go ahead and highlight these again so I get the proper percent. We're looking 25 and 10. Is going to be the 10% to the n, which in this case is going to be 25 minus 1 over r, which would be 12%. Then we can solve for p. That's one way you can do it. Obviously, in Excel, we'd probably want to use the future value formula as opposed to the mathematical formula. And we might be asking the same question and say, well, I would like to kind of use that same algebraic format, but be able to use the function of the future value of an annuity function. So in other words, if I went to my future value of an annuity, which we'll do over here, this is going to be equal to the future value of an annuity. We have the rate, the number of payments, and then the number of periods, and the payment, and then the future value. Usually you get to the end result being the future value, but what if I know the future value and I want to get to one of these other unknowns? Can I still do that as I typically can with an algebraic equation? And we can do that, and we'll do that with the use of a tool called GoalSeek. So this is going to be a practical tool that we can use. So we'll practice that as we go here. So if you're working a book problem, they might give you, of course, the formula and then force you to solve for P. You could do that. I'm going to use goal seek here, however, and we'll first kind of get into the idea of goal seek by writing this out into our normal kind of format, or basically our Excel type of format of this algebraic equation. And then we're not going to rework it to solve for P, but instead use trial and error, use goal seek to then find the answer. So what we want to find is this present value, or this is the payment. Should be the payment that we're going to have. That's what we want to find. We don't know it. I'm not going to leave it 0. What I'm going to do instead is put some number in there so that we can then go back and add to it. So let's put 10,000 on the payment. I'm sorry, let's put 1,000 on the payment. 1,000. And then we're going to go down and do the rest of the calculation, and then we'll go back and adjust this number with the use of the goal seek function. So then we're looking this times this. So we got the P here, and I'm looking at the this side of it, the numerator going to be in the inner column. So we got the 1 plus r to the n. So this is going to be 1, and then the rate is going to be r, which now is 10%. We're going to percentify this, go into the Home tab, numbers, percentify it. We will then underline it, Home tab font, underline it, summing this up equals the SUM, sum of those two items, percentify it again, Home tab, numbers, percentify. Then we're going to take this to the power of 25, the number of periods. So this is going to be equal to the 25, power of 25. Bringing this out to the outer column, this is going to be equal to the 110, shift 6, caret 25. That's going to give us this number. We're going to add then some decimals to it. We're going to say then we want some decimals. Actually, let's keep this one actually in here. I'm going to bring it in here. I'm going to underline this, Home tab font, underline. This is going to be equal to the 110 to the caret shift 6. Caret is shift 6. That's not shift 6. Caret 25. And then we'll add some decimals. Home tab, numbers, add a few decimals there. So there we have that. And then we'll subtract out the 1. So 1, Home tab, numbers, underline. I'm going to bring this out to the outer column now because now we have the entire numerator in essence. This is going to be this item minus 1. Adding some decimals, Home tab, numbers, add a few decimals here. And now we're going to divide it by r. R is going to be the denominator. R is going to be the 10%. Let's percentify that. Home tab, numbers, percentify, and underline. Home tab, font, and underline. So there we have that. We got the numerator and the denominator. Let's go ahead and divide them. Numerator divided by the denominator. And then we'll add some decimals. Home tab, numbers, adding a few decimals there. Underline, Home tab, font, and underline. And now we can multiply these together. This is going to be then the 10,000 times this number that we came up with here. So we then get to this 283,471. Okay, so we want to get down to this 202,392. That's where we want to be. So we could do this with trial and error now. I could go back up top and say, well, what if I had 5,000 here and so on, and like 3,000 and so on. And then we're going to keep on using trial and error. We can then use Excel to do that with the goal seek feature. So we're going to use goal seek for Excel to basically back into that number. We'll do that by going to the data tab. We'll go to the forecast, what if, analysis, goal seek. Seeking the goal. What goal do you seek? We want to set that cell to be the 202,392.21. 202,392.21 by changing that cell right there, that 3,000. We're going to say OK, and goal seek seeks the goal and then does it for us. So we basically backed into this number, kind of using an algebraic type of method, using one unknown, but instead of rearranging the formula to solve for P, or memorizing a whole different formula, we can use the same formula and then basically use the same worksheet back into the unknown. Now this will become more useful or more likely to be used in the format of the Excel function. So now we're going to apply that same concept and say, okay, we have the future value of an annuity with the unknown of the payment. So I can't really rework the function, but what I can do is use the same concept with goal seek. So I'm going to do the same thing here. I'm going to put 1,000 this time down here in goal seek. This is the unknown. This is the cell that I'm going to change in order to back into the number that I need to do. This allows me not to have to look for another function to find the payment function or anything like that, but use the same function and then back into that number just as we would with an algebraic equation. If I know that equation, has what I need to find a particular item in it, I'm not going to memorize another equation, just going to solve for the unknown in the one I know. So this is going to be then equal to, and I'm going to say negative to flip the sign, future value, shift 9. We're going to pick up the rate. The rate is going to be the 10%, comma, and then we'll pick up the number of periods. Number of periods is going to be 25, comma, and then the payment, this is what we don't know. So we're just going to plug in a number, let Excel calculate it, and then we'll use the goal seek feature to adjust it. So then we'll say enter, and there it is. And we know where that needs to be. That needs to be at this 202,392. I'm going to add a couple decimals, home tab, numbers, add a couple decimals down here. That's where we want it to be. We could do that manually by saying, well, what if I go 1500 and then increase it up manually? Or we can let Excel do that using goal seek by going to the data tab up top, forecast, what if analysis, goal seek, and then we want to set then this cell to be 202,392. Hold on, I think my finger hit something funny. 202,392.21. And then we want to do that by changing this cell. So then we're going to say OK. And then it does it. We're going to say OK. And so there we have it again. Let's apply the same concept down here to the calculate this per period. And by the way, before we continue on, this of course then would mean that would be how much we would have to put in, right? The 2057.94 is what we would have to put in for 25 years in order to get to the 202,392.21, so that we can then put that money into an annuity at that point in time, and then for 24 years after that, at retirement, in other words, receive the $26,000 per period. So now we're just going to recalculate this item a couple more times just to show how we can do it a few different ways, this time with a running balance type of calculation, running balance type of table. So here we're going to have the payment. We're going to say the payment is going to be then an unknown. We wouldn't know it yet, so I'm going to say 1,000. And then we're going to calculate our running balance type of calculation on this. The bottom line down here, we want to be that 202,392.21. And we can use this kind of complex table and still use our running balance calculation to figure it. So this is going to be equal to the 1,000. This is not the payment. Interest is going to be equal to the 1,000 times the rate, which is going to be the 10%. The payment will be the same, so I'm just going to say equals that prior payment. The new balance at period 2 would be the prior balance plus the interest plus the new payment that we had. And we would just continue this on down. These are approximated. I don't have the decimals on here, but this is going to be equal to the 2,100 times the 10%. Again, there's the interest. We're going to have another 1,000 that we're going to be putting in. The value then is going to be equal to the prior value plus the 210 interest plus the 1,000 payment, and so on and so forth. So now we want to copy that down, but to do so, I need to make this cell an absolute reference, because that 10%, when we copy down, we don't want it to move down. So I'm going to double click on the interest. That 10% is in Z5, so I'm going to put the cursor in Z5, select F4, absolutize in Z5, putting a $sign before the Z and the 5. In other words, that's how you absolutize or make it an absolute reference. You only need a mixed reference, but absolute reference is easier to do oftentimes. So I'm going to then select those cells, fill handle, drag this on down to the bottom, and there we have it. Now this bottom line number needs to be 202,392.21 once again, and we can do our trial and error type of thing. Up top, I can change this and say, well, what if this was like 1,700, and so on and so forth. Or we can use the goal seek to do that for us, even in this kind of more complicated or table type of format. So we're going to do that again. Data, we're going to go to forecast, what if, goal seek. We want to set that cell to be 202,392.21. We want to do that by changing this cell up top, the yellow cell, and then OK. And then it does it again. Excel totally did it again. So there's the 202, 392, 21. All right, let's do it one more time with the tables. Table time. So we don't know the amount. What we do know is the end result. The end result needs to be at that 202, 392, 21. And we know the table. We can pick up the table amount because we have that information. It's at 10% and 25. So 10 and 25 are what we're looking at here. 10 and 25 is down here. That's going to be the 98.347, 98.347, 98.347, 98.347, 98.347, 98.347. So then we can back into this first number because normally it's the amount times the table gets us here. So that means this number should be the end number divided by that 98.3470 to get us once again to the 2057.94.